Okay, we're going to talk about radicals today. Okay, radical function. Okay, the basic radical would be y equals the root of x. So we have a restriction on this domain. Obviously, we cannot square root a negative number. So we therefore know that our domain has to be that x is greater or equal to 0. Okay, so if we want to graph this, why don't we try to do some x, y coordinates to help us out. So if x is 0, the square root of 0 is 0, right? If x is 1, the square root of 1 is 1. If x is 4, then the square root of 4 is 2. So as we can see, that our graph would start to look like this. Okay, so obviously the next point would be 9, 3. Okay, so relationship would be that x has to keep increasing a lot for y to increase a small amount, right? So that's kind of the relationship of a radical. Now let's look at some transformations. Okay, so when I look at this, I can see two transformations. The x value is being changed, and that would be 3 to the right. And then the +2 transformation moves this graph up 2. So that means our starting point is now going to be 3, 2. And nothing changes with our pattern, so I'm going to go over 1, up 1. And then I'm going to go over 4. So 1, 2, 3, 4, up 2. From the starting point is where I did that. Okay, so this would now be the point 3, 4, 7, and comma 4. Okay, so if I ask you the domain, it would be from 3 to infinity, all the possible x values, and the range would be from 2 to infinity. Okay, so that would be all the possible y values. Okay, what if we have a transformation -2 root x? Okay, so two things are going on. This is a reflection, and we are reflecting it over the x-axis because we're going to be changing the y values, reflecting over the x-axis, or that it's a vertical reflection. And then we have a vertical stretch by 2 as well. Okay, so you can, doesn't matter the order on these ones. So when I look at my reflection, it's going to kind of do that. And then when I do my stretch, I'm now going to go 1 over 2 down. 4 over, so 1, 2, 3, 4 was normally 2, so now I'm going to go 4 down. Okay, and the domain and range. So the domain, the x values can go from 0 to infinity, and the range can go from -infinity to 0. Okay, let's do another one here. Y equals the square root of 5 minus x plus 2. Okay, now this is a little bit tricky because I like this represented with my x and in order to have that, I actually have to factor out a -1. So I'm going to go -1, and now this can become an x. So now I know how to compare it with my basic function, and then this is actually now going to also be a -5 there. Okay, so now I can see that this causes a horizontal reflection. So it reflects over the y-axis, and then this moves it right 5 and then up 2. Okay, so this must be done in the proper order. So my first thing is a reflection. Okay, so you can kind of see, I'm just going to draw a general picture there, reflect, and then from there I'm going to move 5 right and up 2. So there's my starting point, and the pattern is still going to be the same because we didn't have any compression or we didn't have any vertical stretch. So my pattern is still going to be over 1, up 1, over 4 from the starting point, 1, 2, 3, 4, up 2. Okay, so you can see that this point ends up being 1, 4, 4, 3, 5, 2. So 5, 2 is my starting, and then you can see my pattern, 1 over 1 up, 4 over 2 up. The domain would be from -infinity to 5, and then it stops, and then the range would be the lowest of 2 and highest infinity. Okay, what if I give you the graph and you have to develop the equation? Okay, so I'm going to give you the point -1, -3, and then y-intercept -2, and then the point 3, -1. Okay, so on this, we have to make any decisions about reflections. There was none, right? Because it still goes that way. No reflections. The pattern, was there any horizontal compressions or stretches? Nope, because I'm still doing 1, 1, 4, 2. So my starting point has changed. So now I went left 1 and I went down 3. So my equation would be y equals the root of x plus 1 subtract 3. Okay, another example. Let's go the point 0, 0, and then the point -1, 3. Okay, so the first thing I would think about is that this obviously would have got reflected horizontally. So I would have had to do a -x in there. Then I'm thinking my 1 over 1 up is not the same. So now there's a vertical stretch of, instead of 1, 1, I went 1, 3. So my final equation would be including a vertical stretch of 3 and reflection. Okay? Alright. Find an equation if I only give you the domain and the range. Okay, so that means if the domain is from 4 to infinity, then I would have had to start here and go to the right. And my range is 2 to infinity. So I'm 2 going up. So going up and up. So therefore, I change the starting point. You could also make any kind of horizontal shift or any kind of vertical stretch in here. Both would work. So your final equation could be an example. That, and like I said, you could put a horizontal compression or a vertical stretch in there. That's not going to change the domain in the range.